Load factor is a concept quite unique to flight mechanics. To discover it, we will go back to Newton's law first, comparing accelerated and uniform motions. We will then define precisely the load factor vector. Yes, load factor is a vector, it is not just a number. And we will finally look at some situations where we can actually experience this load factor. Newton's law tells us that in the general case, mass multiplied by acceleration is equal to the sum of external forces. Here, the weight, the thrust F, and the aerodynamic resultant R. At equilibrium, typically in level flight or when climbing or descending at constant speed, acceleration is zero. We can then write minus mg equals external forces other than weight. So, in other words, external forces exactly balances the weight. As we are spending 99% of our life at equilibrium, that's what we are used to. We commonly consider that forces are balancing other forces and the weight rather than creating an acceleration. Now, coming back to the general case of accelerated motion. I can move the weight to the left part of the equation and put the weight value mg, the number, not the vector, in factor. I then obtain minus mg multiplied by g over g. It is a complicated way to describe a unit vertical vector directed downward, minus my actual acceleration dvg over dt, divided by gravitational acceleration g, equals the sum of external forces other than weight. The term in the parenthesis is a dimensionless vector that we call the load factor vector n. We can now rewrite Newton's law in the general accelerated case using the load factor. We obtain a very simple expression. Minus mgn equals external forces, very similar to the equilibrium case. This means that we have the same external forces as if the aircraft is at equilibrium and weight is replaced by a pseudo-weight mgn applied in the direction of vector n and multiplied by the value of n. Let's see why load factor is such a useful concept. As the airplane doesn't fall apart, all the internal parts of the airplane, the fin, the landing gear, the pilot seat, and even the pilot eyeballs, stomach or brain have got roughly the same trajectory, or at least they have parallel trajectories as shown on the sketch here. This is true as long as rotation motion of the airplane can be neglected. Having the same trajectory, they all have the same speed and consequently the same acceleration. And as the gravity acceleration g is also identical, all those parts experience the same load factor. So, the external forces applied to any part of subpart or sub-subpart of the airplane have to balance mgn, which means its own weight mg, multiplied by the load factor n. So, for example, during a pull-up with a load factor of 2, a 2G's pull-up, my shoulder have to support 2 times the weight of my arm.